This is problem number 35 from the August 2017 Algebra Regents exam. In this question, we have two inequalities, a system here, and it wants us to solve it graphically on the grid. First thing we want to do is rewrite these inequalities in terms of y. So let's start with the first one. We've got 3x plus 4y is greater than 20. So we're going to try to isolate y. We can start by subtracting 3x from both sides. So we would get 4y is greater than negative 3x plus 20. And then finally, we would divide everything by 4. So we would have just y left over. So y is greater than negative 3/4 x plus 20 divided by 4, which would be 5. And the reason I'm writing it in this style is that it's in slope y-intercept form, right? So we know in this case the slope is negative 3/4 and our y-intercept is 5. That's going to make our lives a lot easier when we have to graph it. Now let's try the other one. So we've got x is less than 3y minus 18. So we can start by adding 18 to both sides. We would get x plus 18 is less than 3y. And then finally, we were going to divide everything by 3 to get y completely isolated. So we would get 1/3 x plus 18 divided by 3 gets us 6 is less than y. And of course, we want to write it properly where y is on the left-hand side. So I'm going to flip everything around, including the symbol, and we'll get that y is greater than 1/3 x plus 6. So in this case, our slope is 1/3 and our y-intercept is 6. All right, to graph this a little bit easier, I'm just going to zoom in a bit. Okay, right around there. Let's draw our x and y axes. It looks like, I don't know if there's a center point here. Let's just make this the center. And this looks about right too. All right. So our first inequality had a y-intercept at positive 5. Yeah, that's right. 1, 2, 3, 4, 5. So that'll be right on here. And a slope of negative 3/4. That means we could go 3 down and 4 to the right. 1, 2, 3, 4. So right there. Again, 3 down, 4 to the right. And also we could go the opposite way. So 4 to the left and 3 up from here. And there we go. Now remember that our solution is that y has to be greater than this line, not greater than or equal to. So instead of drawing a solid line, we're actually going to connect them with a dotted line, which implies that our solution does not include this line itself, but in fact everything above it. So let's go ahead and highlight everything above it. Okay, so we've got that one solved. Moving on to the second inequality, we had a y-intercept of 6. So that's right there. And a slope of 1/3. So that would be a rise of 1 and a run of 3. So 1 and 3, 1 and 3. And go in the opposite direction as well. There we go. And same thing, the inequality said that y had to be greater than this line. So again, we're going to be drawing a dotted line going across. And our solution set is anything above it. So this time, let's draw some horizontal lines. So we can see combined, here, let me just reset the zoom here. Combined, the solution for the whole system would be everything that's above both of them. That would be this highlighted region here. And we'll label that like they wanted with an S. Moving on to the final part of the question, it says, is the point 3, 7 in the solution set? And explain your answer. Let's zoom in a bit and figure this out. So 3, 7, where would that be? Let's take a look. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So that's this point right here. So you'll notice that it's right on the cusp of the solution set. And because our solution set does not include anything along that line, this number or this point is actually not part of the solution. It's pretty darn close, but it's not quite because our solution set is anything above the line, not including the line itself. So an explanation for the answer, I would say something along the lines of no, the point is not part of the solution set because the point is on the boundary line, which is not part of the solution set. The solution set must be greater than the dotted lines. And that would be a pretty good explanation. All right, I hope that's helpful, and thanks for visiting JD's Regents Preparation.